If you've been following along in this series and have watched a previous recording on virtual machines, you'll see that there was a potential issue with a standalone single virtual machine, whether it be in your environment or in Azure. I want to introduce the topic of high availability and things that you can do to get yourself up into a 99.95 high availability capability. My name is Bob Tickleman. I'm excited to be your guide on Azure Virtual Machine high availability. Let's get into this. Within the virtual machine environment, there's quite a bit that you can do to manage the virtual machine. That's not what this is about. We want to get into the availability options and the things that you can do to not create a career limiting move or a resume generating event. Having a single point of failure in a production environment these days is not a great thing for a career to have it go down. There is enough opportunities at a very inexpensive cost to be able to provide these high availability options to you and your organization. We're going to take a look at what Azure provides, from scaling capabilities to scale up or scale down, as well as to scale in or scale out. Now, I do want to just take a minute as I describe that. Scaling up or down is going to allocate more resources to a specific operation. If you have a compute-bound resource that you have an application, let's say it's single-threaded. I'm going to make this very simple because you might have multiple users using it that is going to drive compute requirements. But if I have a single user using a single thread and I tie up all the CPU, adding another virtual machine is not going to help you because that single thread is the bounding resource limiting feature. And having another virtual machine with another thread that can't be used doesn't help you. The only way to resource fix this is to scale it up, give it more of that, give it more compute. So scaling up is a high availability component to fix resource allocation constraints. Now, if your resource allocation just comes from load, now you've got hundreds of users coming to your application. So you have hundreds of threads that are running. And that now is what stretches the capacity you're working with. Adding additional resources to add additional threads and spreading those threads across them is a scale out and a scale in resource. So I just want to make sure that that's a clear difference as we go through this course. So we're going to get in, take a look at what downtime is and how to manage this to give yourself the greatest capability to have high availability for your application in your organization. Now, within Azure itself, there is a whole set of maintenance that is managed by Microsoft at scale. And we manage our servers just like you do. You know, I've shown pictures in other recordings where we show these massive racks in these massive data centers in these massive regions. That's an even bigger globe. There's millions of servers that we have to patch. We have to do the same things that you do on a monthly basis, but we don't do it the way that you do. You probably have a Windows server that you have to then deploy our monthly updates to that might take an hour or two to run. And during that 2 hours of patch and updating, you have degraded performance. And what happens at the end of those 2 hours? You have to reboot the machine, you cross your fingers, hold your breath, and you hope it comes back up. What happens to the power supply goes down, and then the VM doesn't come back up because of the underlying OS. All of these things were challenges you have. We don't manage that. We've got millions of servers. Hard drives are failing all the time. I was in one of the data centers once, and the data center manager picks up a hard drive and goes, the MBTF, the mean time between failure for this drive, is 10,000 hours. That's years. He goes, but when you get 13 million of them, they're failing every couple of minutes. We don't have enough time or resources to run around and fix those drives. So guess what we do? We let them fail. We've got enough drives that we just mark it as a dead drive. We put the resources across to others. Remember, in other recordings, I've showed you, we don't do RAID like everybody else. We actually have 3 copies. We don't have a drive that potentially affects 5 other drives. We just put 3 copies across 3 different locations. So we manage at a different scale. And you're going to see in a term that is called a update domain. We don't talk about it much in this course, but I do want to introduce it. Microsoft updates the core infrastructure servers of Azure, and there is tens of millions of them. We cannot put a 2-hour patch process, reboot the process, hoping it's going to come back up. What we do is, the term is called a drain. We drain all the resources off of it, find ways to stop new resources coming in and moving the other ones that are on. Once nothing is on that node, we actually partition and format it and deploy a brand new tested operating system that is already patched. And it happens in a matter of minutes. That is the only way you can do this at scale. So that's going to come into play later on as we take a look at this. We don't talk about update domains in this course anymore, but it might be something you go take a look at. What Microsoft is managing across our infrastructure, you're seeing the unplanned hardware maintenance. We have regular updates that have to be patched. We have drivers that have to be done. We've got, if you want to check, Mark Rasinovich has got videos that talks about how this is done. We can do patch management on a demand requirement in a matter of seconds, deployed to thousands and thousands of servers. Unexpected downtime. That goes to an example that I did in another recording where I said, what happens if the entire node fails? For no fault of your own, it wasn't during a regular patch. And this is where the self-healing feature of virtual machines are going to come through. Go watch that recording and you'll see how that happens. And then there's planned maintenance, which is part of that update domain topic that I was talking earlier, so that we make sure that we have the lowest potential footprint or impact on your use of your resources across our infrastructure. Now, here's the tool belt of tools that you want to have available to you. We're going to talk about this thing called an availability set. This is a group of one or more virtual machines added to a virtual machine set that will work together, typically with a front-ended load balancer, that will perform this activity. This is something that you're hopefully very familiar with and how you've handled high availability in your organization. You can now have this availability set that has these topics I was just mentioning of fault domains and update domains. I want to go off and do a diagram of this and show how it comes into play. And then what you do is you take your virtual machines and you put them into this availability set. Now there's different ways that you can work with this. You could, when you build a virtual machine, you could also build the corresponding availability set. You could build the availability set before, and as you build a virtual machine, you could put it in the pre-built availability set. One thing that you can't currently do, as of this recording at least, you can't take an existing virtual machine and put it into an availability set. It has to be put in at the time that the virtual machine was created. So that's one of the limitations that you might have. And we're going to show availability zones and scale sets, and there's some things that have changed recently. Again, I'm not going to get that deep in it, but you want some of these that are now going to move you from that 99.9% high availability to a 99.95% high availability. Earlier in this recording, we talked about a standalone virtual machine. I'm going to start with just two to see what would happen. So I want you to recall that previous conversation. My two virtual machines are going to be blue VM and green VM. They could be similarly configured. You typically want them to be as close as possible, but they are separate instances of an operating system that you would then have to manage and patch and update separately. That becomes the key here. These are separate virtual machines. They could be very similar. They could be clones of each other, but they are separate. They would be deployed to some location, and using the recommendation we have, the VHD that is responsible for it is going to have its 3 copies across 3 different fault domains. Remember, these scale units are our fault domains. 3 copies of my C drive for my blue virtual machine across these 3 different fault domains. I could have a load balancer that is front-ending this that then sends the traffic to those 2 virtual machines. Let's say they are both at 70%. Things are pretty good. More load comes in, and now they're both at 100%. And now I've got load that's being rejected. It comes in and bounces back because I don't have any load. You've hit a capacity. What do? You could potentially scale those virtual machines out to give each one more capacity, or you could add more virtual machines to your availability set. So now I take that load and I'm going to spread it across multiple machines, bringing them back down to 70%. I'm going to say they're not real busy right now. Let me do this. Say they're at 50%. These are 3 separate machines. What do you have to do with your machines on a monthly basis? You have to patch your monthly machines. So for 2 hours, you are going to run through a patch process against a virtual machine. During that 2 hours, it's going to be degraded performance. What happens at the end of the patch? You have to reboot that virtual machine. So for a period of time, it's going to disappear. What's going to happen to your load? It's going to go to the other machines. Now, it's great that they're at 50%, so I'm going to add 25 to both of them. So they're still within the bounds of them being able to have that workload. But what happens if they're not? What happens if they were all at 70% or 80%? That 40% is going to put those other machines over their constrained limit or over their limits of their resources. And now I'm going to have potential problems again. So this becomes the issue that is the foundation of how many virtual machines do I have to put into an availability set to handle the load, not just during standard operations, but how do I do my updates? And what is going to happen? Do I do multiple machines at once? And what's going to happen to the load? So these are machines that you manage individually across your availability set. Now I'll come back to this in a minute. So you're seeing an availability set is the definition of a grouping of, I say 1 or more because you can have 1 in it, but it's not really an availability set, 2 or more instances. And you could put 5, 10, you could put hundreds of virtual machines inside of that availability set. They share a common region. And then what you talk about is this thing called a fault domain. Now you can have up to 3 fault domains, and you can have up to 20 update domains. What this means is, and this number 3 is very specific, remember how many copies of your hard drive there are, you can put them into 3 separate fault domains so that machines will then have the capability to have, I'm going to go through, maybe I got 6 machines, so I'm going to have 2 in one fault domain, 2 in another fault domain, 2 in another fault domain. So it's going to spread them across a fault domain so that they have no single point of failure that they're working with. Now the update domains, and I run into this problem all the time with customers, they think it's the update domains that you provide that I was talking about, the updates that you do on a monthly basis. It's not the case. These update domains are the ones that Microsoft does. Remember those nodes. We are going to have to drain your services off and move your VM across to another virtual machine. Let me just go back there for a minute. So for your blue VM that's running on that node, I have to put a drain command around it that says, do a live migration and move that virtual machine off to another node. So when we finally get nothing on that node, we are able to update the domain. That's us updating it, because we don't want to update it while you're using the virtual machine. Well, you don't want us to do all the nodes in a stack all at the same time. You don't want us to do a whole bunch of these all at the same time, because in fact it might have multiple impacts on multiple of your VMs in your availability set. So by spreading them across up to 20 update domains, you're going to spread your machines across 20 virtual machines that we will never update at the same time at our level. So we manage that so that we're not going to impact 3 or 4 or 5 of your machines of your only 2 or 3 or 4 or 5 machines that you have. So the update domains is a Microsoft update, and you can put them across multiple domains to minimize the potential impact. We introduce a concept called an availability zone. Now this again is not available in all regions yet. And a zone, remember, provides high availability across data centers inside of a region. So this is still a regionally based deployment. And so now what we have is, this is going to be data center number 1. This one may be data center number 2. This is data center number 3. This is data center number 4. Got data center number 5 and data center number 6. Inside of them, we still have our fault domains. And inside, we still have our update domains that says, this is update domain 0, this is update domain 1, this is 2. So we would never do those 3 VMs at the same time. They would be done one at a time to minimize the potential impact. An availability zone provides data center redundancy across the region. It's in a region, it's independent of power and cooling, and provides for data center failures now. I still have high availability because my application is running in 2 other data centers inside of that region. an availability zone. This is where we talked about, and I did a bit of this at the start of the module itself. Vertical scaling makes bigger instances, but it may not fix your resource constraint. It is up to you to determine what is being constrained from a resource and why, because vertical scaling does not always fix the issue. Horizontal scaling doesn't always fix the issue. So what is the issue that you're trying to fix, and pick the right type of scaling. So this is often referred to as scale up and down. You'll see this in the demonstration. And this is scaling out and in. So you can dynamically scale your machines in and out that you're working with. So you can add more VMs or take VMs out of it if it was an availability set or an availability zone. There's another type of scaling that is available called a scale set, which is going to fundamentally change the diagram of how our availability is going to be working. So I'm going to go back to that whiteboard session, and then we're going to come back and take a look at how availability zones and sets are going to be different than scale sets. So in this diagram, we had built either an availability, in this case set, and if it was across multiple data centers in the same region, that would have been an availability zone. These are 3 different virtual machines managed separately that you're going to have to patch one at a time. I could add another one if I wanted. It's a manual process, and if I didn't need it, I'm still paying for it. So what I want to do is change this. So remember what we just had. We had various different virtual machines, very similar, managed separately. A scale set is going to use a master image, still backed by a load balancer, that is going to take the load, and its back-end pool is going to be the scale set. If you remember, we talked about load balancers in a recording, and then we talked about the different types of back-end pools that you could have for it. This would be your scale set. Now I'm going to draw green VM here. I'm going to call it V1, version number 1. You then create a scale rule for green that has a minimum, a maximum, and then you can either manually or automatically scale it. So I'm just going to call it a rule. So I'm going to say you have a minimum of 2 and you have a maximum of 1,000, which is currently the maximum limit you can have in a scale set. What it does, it needs a minimum of 2. So guess what it's going to do? It's going to put, I'm going to put number 1 here, and this is a V1 of green. And it's got its 3 copies of its hard drive. This is going to get a little confusing here. I need 2, so I'm going to have VM number 2, and it's got its 3 copies of its hard drive. And this is a V1. My scale rule says when they're at or above 70%, add 2. So these are running, they're both at 70%. So the rule is add 2 more. So I'm going to get number 3. I'm going to get its 3 copies of its hard drive. And I've got number 4. Now depending on number 4, depending on the fault domains that you're working with, all these are going to depend on how they're going to be spread across, but I've got my number 4. That's great. And if I need more, this process will continue to repeat. Here's another benefit of scale sets over availability sets. These are all copies of a single master. If it has 1,000 VMs, do you want to update 1,000 VMs? No. What you do is you create a new version of the master. And when you do your update, what it does is it puts that drain command that I've used before. It's going to put a drain around number 3 here to say any new inputs, bounce it off to someplace else. If it's got a long-running thread, they stay there. But what it does then is it spins up number 5 of a V2. And once V5 of V2 is up, and no more work is on number 3, it goes away. So that process in a scale set is a great way to organizationally manage your entire update process, giving you the exact amount of resources that you need to be able to work with this. Now, there is a rule around scaling. I'm not going to get into it just because I've spent so much time on this. I encourage you to watch another recording on app service plans that follows the same scaling rules that we do here. And in that module, instead of repeating it, I've decided to allocate time here for the VMs, and the scaling conversation on how to scale is going to be covered in the module on app service plans. So go watch that one if you want to understand the rules that you can build and how to manage this. You're seeing some of those scaling rules here. As I said, that's the reference to the other module recording that you may want to go take a look at. So let's go take a look at what this looks like in a live demo. I want to show you the options of creating availability zones, availability sets, and scale sets. I'm just going to do the creation piece. We have, especially for the scale sets and the scaling rules, that's going to be done in another recording because it's quite an involved process to be able to create those rules, and I want to have you understand it. I just want to show you how to create them now. There's several ways that you can do the availability zones and the availability sets. They can be pre-built, which is what I'm going to do here, or you can build it at the time that you build the first virtual machine that goes into the availability zone or the availability set. So I can go through the process and I can actually create an availability set. And it's fairly simple. You know, what resource group do you want to add it to? What is the name of it? I'm going to call it pre-build. There's those features. Which region do I want it to be in? What is the fault domains? The maximum of 3. We can get up to 20. And there's very little else that you can do. What is the advanced tabs, the tags? But this is basically what you just create, and you've got an availability set pre-built. The second way can be done when you're building the first virtual machine that's going to go into an availability set. I'm going to do basically the same thing. You've seen this when I built virtual machines. I'm not going to fill all of it in. I'm still going to stay in US West 3. And from an availability options, you can see that I have none, an availability zone, set, or availability set. So I'm going to pick set, and it now brings up a new field that wasn't here before. I can pick from an existing one. There's my pre-built, or I can create one at this time, and it's going to give me basically the same options. Come on. Where I'm going to give it a name, the fault domains, and the update domains, and it comes back. So you can create an availability set beforehand, pre-built, and then pick it. It has to be in the same region, or you can build it at the same time you build the first VM. And then any additional VMs you add afterwards, when you build it for the first time, you could then pick it and put it in to add to them. So that's the availability set. Looking at availability zones, is it self-selected zones, or do you want the Azure to select it? And if you remember the whole conversation, we talked about availability zones. You have 3 of them within the region. You don't get to pick which data centers, but now I can self-select. This virtual machine is going to go into this zone, zone 1. This one's going to go into zone 2. And so it's up to you to balance the load. And you want to be careful, especially as you're deprecating VMs, or maybe adding, if people are randomly doing it, they may be putting them in and putting too much burden on one of the zones, because it's up to you, where the Azure selected zone is a feature that will then evenly put the VMs across the zones in an equal distribution. The scale set can be done, as I said, as a pre-built or at the time I pick it. So I'm going to get into my virtual machine scale set. And again, I'm going to be asked to create the scale set if there isn't one already. I've got one, VM scale set demo, or I can create one now. And it's going to basically go through, do I want to manually scale it? Do I want to auto scaling? And this configuration is what I'm going to do in another recording. Look for it. It's under the app service plan. That's where I'm going to get in and talk about scaling rules and how many rules you can have and how do you scale them out and scale them back in. But for now, you now know how to build this high availability using the Azure portal. Let's return to the lecture. In addition to the high availability options that we've covered in this module, there's one more topic that I want to cover for you. I've introduced the term several times called IaaC, or Infrastructure as Code. And it's been a long practice at Microsoft. We've had a whole series of products, MOM, Microsoft Operations Manager, System Center Configuration Manager. We've had all these different products that allowed you to deploy and manage at scale hundreds, if not thousands, of devices. Microsoft Azure Arc is a cloud-hosted service that provides a centralized manage of your infrastructure in a cloud environment. And it takes cloud management constructs, not only because we've talked about in other recordings about using templates and policies and governance that you have to control all of these capabilities. Azure Arc now extends that capability. It manages in a single pane of glass, our fancy marketing term, in a single location, a single pane of glass. You can manage all of your Azure services, all of your on-premises devices, as well as other cloud environments through this single pane of glass. And so that's what they're showing you here as a management tool to now take at scale the management of your resources for high availability. So these topics in total cover a wide variety of high availability capabilities that you can now bring to the architecting and the deployment of your solutions. Now, in addition, we haven't covered all of them. Remember, there was in storage, we talked about region pairs and the ability to actually replicate storage accounts. We've got other products like Cosmos DB that is a global service. We've got Traffic Manager. We've got Front Door Services as a global cloud scaler for routing traffic. There's other pieces that, in addition from the IaaC, or Infrastructure as Code, to provide that traditional workload, Azure Arc is going to provide that capability, as well as other ones that we'll be doing in other modules, taking a look at containers, container management, Kubernetes, app service plans. All of them fall under the purview and management of an Arc environment. But all of them provide for high availability. And what you've seen here specifically, we focused on virtual machines. Thanks for joining us for this session. To continue your learning, watch other videos in the course or explore more on Microsoft Learn at aka.ms/learn.